Hello viewers, welcome back to my channel. In this video I am discussing linear algebra tricks for CSR net and KSET aspirants. This is the very important video for all the IR mathematics examinations aspirants who are preparing for TAFE, for GATE, IIT JAM, CSR net and BHU and many other entrance examinations. Okay, I will starting now. The first result is a number of non-trivial entries in the upper or lower triangular matrix of order n is n into n plus 1 by 2. Okay, if you want proof, I will uploading in next video. Okay, this is only for results and tricks video only. Okay, and next one is a number of non-trivial entries in the strict upper or strict lower triangular matrices of order n is n into n minus 1 by 2. And next trick is number of non-trivial entries in the set of all matrices of order n which commute with diagonal a1, a2 and so on, a1 and a2, a2, a2 and so on, a2 and so on, am, am and so on, am. Here a1 is p times and a2 as q times and am is r times is p square plus q square plus and so on plus r square. Okay, next result is if sum of elements of each column of each row or column of square matrix of order n is k, then sum of the elements of each row or column of a power of m will be k power of m, where m belongs to n. This is very important result because based on this result, number of questions asked in CSR net, I am already uploaded one question, one or two questions in my channel. Please watch that video. You get the idea about this result. Okay, next trace of a matrix. Trace of A is sum of diagonal elements, sum of diagonal. And suppose I am taking one diagonal, I am taking one example. Suppose we take one matrices 1 2 3 4. Here the trace of this matrix, if this is matrix of A, then trace of A is equal to sum of diagonal entries, these 1 plus 4, that is 5. Okay, then some results of trace of A is the trace of A plus B is equal to trace of A plus trace of B, and trace of AB is equal to trace of BA. Based on this result, number of questions asked in CSR net examination. Okay, very important result. And transpose of a matrix. Transpose of a matrix denoted by A transpose and defined as a matrix obtained by interchanging rows and columns, that is row to column. That is suppose we take one example, suppose we take this as example, then A transpose is equal to which interchange the row to column and column to row. Suppose this is column, I am written in the row form 1 3, and this is written is 2 4. This is the transpose of this matrix. Otherwise we interchange column also. Okay, we interchange column, we get 1 2 and 3 4, we get same. Okay, we A transpose means we interchanging row to column or column to row, that is transpose of the matrix. The sum results of transpose of the matrix is A transpose of whole transpose is equal to A, and k of A whole transpose is equal to k into A transpose. Here k is any constant scalar. Okay, and third property is A plus B whole transpose is equal to A transpose plus B transpose, and fourth property is AB whole transpose is equal to B power of B transpose into A transpose, and fifth property is A transpose whole power of M is equal to A power of M whole transpose. This is important result. Remember this result. Okay, conjugate of a matrix. What is conjugate of a matrix means? Suppose we consider one example. This is matrix A. Then conjugate of A is A bar is equal to Bij m by n, where Bij is equal to A bar Ij for all Ij. Suppose I am taking one example. I am considering one matrix A, that is suppose 1 iota 2 minus iota. Suppose this is the conjugate matrix. Conjugate means in conjugate matrix the matrix containing complex elements are reals. Okay, suppose I'm considering this example, then conjugate of this matrix is 1, and in iota we take minus I and 2, and 2 minus iota is written as 2 plus iota. Okay, this is the conjugate of this matrix. Okay, then conjugate transpose of a matrix. What is conjugate transpose of a matrix? Okay, let A is equal to Aij m by n, then conjugate transpose of A is A theta is equal to Bij whole n by m, n by m, that is Bij is equal to A bar Ji. Okay, this is the conjugate transpose of a matrix is this is the conjugate. We take the transpose of this matrix. Okay, we get 1 minus I and 2 plus iota. This is the conjugate transpose of a matrix. Okay, then some properties of this matrix, conjugate of a matrix is a conjugate whole conjugate is equal to A, and A plus B whole conjugate is equal to A conjugate plus B conjugate, and A conjugate whole power of m is equal to A power of m whole conjugate, and AB conjugate is equal to A conjugate into B conjugate. This is some results of properties of conjugate of a matrix, and we understand conjugate transpose of a matrix also, and the some results or properties of this conjugate transpose of a matrix is AB whole transpose with this theta indicates the conjugate transpose of a matrix. Okay, is equal to B power of theta into A power of theta, and idempotent matrix. Then this is the property of this, and next is idempotent matrix. This is the one of the special type of matrices. Okay, this is the very important matrices. Remember this type of matrices, some special type of matrices. This type of matrices we call as special type of matrices. Idempotent matrix means A square is equal to A. Okay, here A is idempotent, then B is equal to I minus A is also idempotent. Okay, then nilpotent matrix, this is also special type of matrix. A power of m is equal to 0. There exists positive integer m. Okay, here m is a positive integer. M belongs to positive integer. And null matrix is always nilpotent matrix. Okay, if A and B are nilpotent matrix with commit with each other, then A plus B is also nilpotent matrix. Okay, then some results of nilpotent matrix is if A and B are nilpotent matrix with commit with each other, then A plus B also nilpotent matrix. We know that result, and index of A plus B is then some results of nilpotent is index of A plus B. Okay, here A plus B is two nilpotent matrices is less than or equal to index of A plus index of B minus 1. This is important results. Remember these results. If A and B are nilpotent matrices with commit with each other, then their product AB is again a nilpotent. Okay, index of AB is less than or equal to minimum of index of A comma index of B. Then next matrix is involuntary matrix. This is also one of the special type of matrix. A square is equal to identity. Identity I and minus I are always involuntary matrices, and even power of involuntary matrix is identity matrix. Okay, odd power of involuntary matrix is itself. Okay, if A is involuntary and idempotent, then A must be identity matrix. Suppose if any given matrix is identity matrix, that matrix is both involuntary as well as idempotent. Remember this point. Okay, if A is idempotent and nilpotent, then A must be null matrix. Okay, suppose if any given matrix is null matrix, then that matrix is both idempotent as well as a nilpotent matrix. Okay, symmetric matrix, then this is also one of the special type of matrix. A transpose is equal to A, okay, and skew symmetric matrix, A transpose is equal to minus A, or A is equal to minus A transpose, okay. Then A is any square matrix, A dash is always symmetric, okay. A plus A transpose is always symmetric, and A minus A transpose is always skew symmetric, okay. Then next um, matrix is Hermitian and skew Hermitian matrix. This is a complex matrix, okay. This is complex matrix. Hermitian is A theta is equal to A, and skew Hermitian is equal to A theta is equal to minus A, okay. All the diagonal elements in the skew Hermitian matrix are pure imaginary or 0. This is very important result. Remember, suppose I am taking one example, 1 2 0 1 0 1 0, okay. I am taken this example here, minus 1 we take, okay. This is the example. All the diagonal elements in the skew Hermitian matrix are purely imaginary. This is the skew symmetric matrix, okay. This is the skew Hermitian and symmetric matrix. Here 1 is there, minus 1 is there, and diagonal entries are 0. Therefore, this matrix is a skew Hermitian matrix, okay. Okay, remember this point, okay. And null matrix is this is not only skew Hermitian, this is skew symmetric matrix also. This is skew symmetric matrix also, okay. Skew symmetric matrix, this is skew symmetric matrix, okay. Remember this point. Suppose we here iota, here minus iota is there, this is skew Hermitian matrix. If reals all the matrix contain all the elements are real, then this is skew symmetric matrix. If this matrix contain any complex numbers, then this is a skew Hermitian matrix, okay. Then null matrix is only Hermitian as well as a skew Hermitian. Null matrix is only symmetric as well as a skew symmetric matrix, okay. Then orthogonal matrix, this is the very important special type of matrix, okay. Every time in the exam, CSR net and many other entrance examination, especially KSET also, based on this type of matrix asked in number of questions, okay. A into A transpose is equal to I, or A transpose A is equal to I. A is orthogonal matrix, then determinant of A is equal to plus or minus 1. If A is orthogonal matrix, then A is non-singular and A inverse is equal to A transpose, okay. Product of two orthogonal matrices is orthogonal, okay. Total number of submatrices of all possible order 2 power of m minus 1, 2 power of n minus 1 is, okay. Suppose I am taken one example. Total number of submatrices of all find the total number of submatrices of this matrix, okay. Simply I am already given the formula 2 power of m minus 1 into 2 power of n minus 1. Here m is equal to 3 and n is equal to 4. Here 2 cube minus 1 and 2 for 4 minus 1. Solve this, we get the answer, okay. Then determinants, this is the determinants. We know the determinants, okay. Here one of the special type of matrix determinant. Here in the given matrix in the form of like this, A 0 0 0 0 B 0 0 and B 0 and 0 A B 0 0 0 B A 0 0. Here all the diagonal elements and the principal diagonal entries are A and non-principal diagonal entries are B B B B. The form up like this, then the trick is A square minus B square whole power of n by 2, okay. Here n is order of the matrix. We are see this here, n is equal to 6, therefore A square minus B square whole power of 6 by 2, that is A square minus B square whole cube. This is the determinant of this matrix. Okay, then invertible matrix, if determinant of A is not equal to 0, that is non-singular matrix is said to be invertible matrix, and determinant of A is equal to 0 is singular matrix. If we have to find determinant of any matrix which contain variables, then replace it by numbers and select answer from option. Suppose if they are given any matrix in the form of like this 1x and x square and y z and y and 1, the suppose the matrix is given in the form of like these variables, then we directly take some real numbers. We take numbers. Okay, we take, suppose we take x is equal to 1, y is equal to 1, z is equal to 1. Based on the given matrix, we take the any real numbers. Okay, according to options. Okay, according to options, we put the values and check the this matrix through options. Okay, this is the trick, remember. And the next result is if A is a triangular matrix. Triangular matrix, upper or lower, or stick upper or stick lower triangular matrix, then determinant is product of diagonal entries. This is very important result, remember. Suppose if they given any matrix, suppose I am taken one matrix 3 by 3 matrix 1 0 2 3 sorry 0 5 2 0 0 1. See this is the upper triangular matrix. This is the upper triangular matrix. Then the determinant of this matrix is the product of diagonal entries 1 into 5 into 1. This is 5. This is the determinant of this matrix is 5. Like this we solve the determinant of the matrix. Okay, then some results of determinant is determinant of k a is equal to k power up n into determinant of a. Here k is any scalar. Okay, and next property is determinant of a bar is of a transpose is equal to determinant of a, and determinant of a theta is equal to determinant of a, and determinant of ab is equal to determinant of a into determinant of b, and determinant of a plus b is not equal to determinant of a plus determinant of b in general. Okay, if we interchange any row or column, its value is multiplied by -1, and any row or column is multiplied by k, the value of determinant is multiplied by k. Okay, this is the some properties of determinant. Other and some other properties also there. If any matrix have same rows or same columns, if any matrix have two same rows or same columns, then determinant of that matrix is 0. Okay, suppose the example 1 2 1 5 6 7 1 2 1. If the given the matrix is the determinant of this matrix is 0, because these two columns are identical, then the determinant is 0. If any two rows or two columns are identical, then determinant of that matrix is 0. Okay, remember this note. Okay, and adjoint of a matrix, a into adjoint of a is equal to adjoint of a into a is equal to determinant of a into I. I am already one video uploaded tricks for adjoint of a and a inverse of a, inverse of the matrix. Okay, please watch that video. We get the idea about adjoint of the matrix. Okay, some properties of adjoint of a is adjoint of 0 is equal to 0, and adjoint of a transpose is equal to adjoint of a whole transpose, and if determinant of a is equal to 0, and determinant of adjoint of a is equal to 0. And fourth property is adjoint of ab is equal to adjoint of b and adjoint of a. If determinant of a is not equal to 0, then determinant of a is equal to mod of a whole power of n minus 1. Okay, if determinant of adjoint of and adjoint of a is equal to determinant of a whole power of n minus 1 into 2. This is very important result, remember it. In general, determinant of a and so on, determinant of a is equal to determinant of adjoint and so on, adjoint of a is equal to determinant of a whole power of n minus 1 into k. This is the very important some results. Okay, in next video I am continuing some other results. Okay, rank of the matrix, system of the linear equations, and eigenvalues, eigenvectors, and Cayley-Hamilton theorem, some results of diagonalizability. Okay, Jordan canonical form, like that. Some results of many results of linear algebra, other results. Okay, I will continue in next video. Thanks for watching. If you like this video, please like, share and subscribe my channel. Thank you.